Okay, now let's continue our discussion on the transformation of distribution. So what is transformation of distribution? If we have a random variable, so this is a random variable x. For every random variable, we are going to have a PDF function. Okay. What is the full name of PDF? Probability density function. And what is CDF? Cumulative distribution function. So what is the relationship between PDF and CDF? If I know CDF, how do I get PDF? If you were given the PDF, how do you get the CDF? If you were given the CDF, how do we get a PDF? Derivatives, right? And f prime x is fx. Okay. Now this is for random variable x. Now suppose we have a random variable y, which is a function of x. For example, here y equals to gx. So y is a function of x. So because x is a random variable, now based on the function we generate another random variable. Okay. So y is a new random variable. But now the question is, what are the PDF and the CDF of y? So this is a question we want to discuss today. Now let's have a look at example. Oops. Yeah. Suppose we have this random variable x. Suppose we know the PDF function, that is f x x, which is actually look like this. So this is x, and this is -1, and this is 1/2. And then we have a function here. So this is 1/2 exponential minus x. In order for this one to become a valid PDF function, so what do we check? The area underlying should be equals to 1, right? How do you check the integration from -infinity to infinity should equals to 1? So that is, when I stand here, did I cover this one? No? Okay, I can see the TV over there. So this is -infinity to infinity, f x x should equals to 1. Obviously, here, this half is 1/2. If you integrate from 0 to infinity, 1/2 exponential minus x, it's going to be 1/2, another 1/2. So add them together is 1. So this is a valid PDF function. Now, if we have another function, y equals to x squared. Now the question is, what is the PDF and the CDF of y? Okay. Now we were given this PDF function. Tell me what is the PDF and the CDF for y, and I tell you the function. So what is this function? This function is actually look like this. This is x. This is y. And y equals to x squared should be everybody. You know, this is y equals to x squared. Everybody agree? Right? Y equals to x squared looks like this. Okay. Now, what we want to get is actually f y y and also f y y. So this is a PDF and CDF function. So this is CDF, this is PDF. Okay. Now, what is this what is this CDF function? This CDF function is actually equals to, so if we know CDF, so if we do the differentiation, we will be able to get this. It's called, if you just differentiation, you will be able to get the PDF function. Now let's try to get the CDF function together. So what is this CDF function for y? Okay. So this will become probability capital Y less than or equals to small lowercase y. Okay. And we will have, because y equals to x squared, so here is actually x squared less than y. Probability x squared less than y. So this will equals to what? When y, you see y, if y, so here if y, this is y. If it's less than y is right here, right? So everything here is y is less than y. And this location will be minus square root of y. This location will be square root of y. Okay. Now, what if y less than or equal to 0? We could equal to 0. So here, let's use less than 0. What if y is greater than or equals to 0? What will be this value? Here, the question is, you see, x squared less than y. So what is x squared? X squared is you take the square of the random variable x. So it's always positive, right? So is it possible x squared less than this y when y less than 0? Impossible, right? Because when y less than 0 is negative. So is it possible x squared is less than a negative value? What's the probability? 0 then. So if y greater than 0, this is actually equals to probability x. So x should be in this range. Now we're looking at this axis. So this axis x should be less than square root of y and greater than minus square root of y. Agree? Is it too small? Okay. So this is actually the y function, but minus square root of y. So, but we haven't finished yet. We haven't finished deriving the answer yet. So, for now, suppose y is less than 1 or greater than or equals to 0. Okay. What is the f? This is the first condition. Okay. Now, what is the fy? Lowercase y. Okay. So here we add one more condition, 1. Y greater than or equals to 0, and also less than 1. Why we need to less than 1? Because here you have a 1 here. So we need to consider whether we are in the middle or somewhere beyond 1. So this will equals to, if we look at this function, if y is between 0 and 1, so here is 0, So this will be the location y less than 0 and 1. So this will equals to, this is the negative square root of y. And then maybe we have a square root of y over here. So this will be the area for this one. So probability x less than square root of y greater than minus square root of y, okay, will actually equals to, you see, what's this half? What's the area of this half? No, this is the area. We are calculating the area. So this length is actually minus square root of y, right? What is the height? Half. So what is this area? Yeah. Which is actually 1/2 square root of y. That is this area. Oops. This area. Then plus the other half. What happened here? Plus actually 0 to square root of y, and then 1/2 exponential minus x dx. So this will equals to 1/2 square root of y plus 1/2 1 minus exponential minus square root of y power. So far we got this one. When y less than 0, this is 0. So if y greater than 0 and less than 1, we got this value. Okay, now we still get one more that is greater than 1. Okay, now let's scroll down a little bit. We have another one. For y greater than 1. So greater than 1, we are going to, for example here, the minus square root of y will come here, will be here, and square root of y, maybe, I think it's not symmetric. Well, let me make it symmetric. Square root of y right here. So we're going to get this area. But it will not go beyond this vertical line because the PDF function only stops here, so you cannot integrate. It's just a stop here and then go down. This is 0, right? So only this area plus this area. So for y greater than 1. So what do we have? Fy will equals to, actually you have the entire 1/2. Entire 1/2 in this side. Then plus 0 to square root of y, 1/2 exponential minus x dx. So this will equals to 1/2 plus 1/2 1 minus exponential power minus square root of y. So far we get, what is the Fy? What is the Fy and y, which is actually has 3 components. If it is 0, if y less than 0, so it will be 1/2 square root of y plus 1/2 1 minus exponential 1 power y if y greater than or equal to 0 and less than 1. It will become 1/2 plus 1/2 1 minus exponential square root of y if y greater than 1. Greater than or equal to 1. Okay? So if we know this, so this part will become, so this is CDF. Now how do we get PDF? Differentiation, right? Differentiation. Now we get f y equals to, if you do the differentiation, this one is 0, and the next one will be 1 over 4 square root of y, 1 plus exponential minus square root of y. So this one is if y less than 0. This one is for y greater than 0, less than 1, and for y greater than or equal to 1. This will be 1 over 4 square root of y, 1, no 1. Here I should have y and exponential minus square root of y. So far, based on x, so x PDF function is not just a regular PDF function. We're trying to have a customized PDF function. Okay? Now, x PDF is given. And then we also know the CDF, because based on the PDF. How to go for the CDF from PDF? Integration, right? So this is integration, and then backward is differentiation or derivation. Now, y equals to gx. So far, this one we are saying that y equals to x squared. Now, if we know the PDF function of the x, so what is a PDF function for y and a CDF function for y? So what we did is we're trying to, based on, first we write down the CDF function for y, and then we put x in, and then based on the x CDF, we're trying to derive x PDF. Okay? We're trying to derive the CDF for y. But this relationship actually is very important for us to get this one. Okay?